I can determine if an ordered pair is a solution to an inequality. Here's what you need to know. To check if an ordered pair is a solution to an inequality or an equation like you've practiced before, just substitute in your x and y coordinates into the equation or inequality and see if you produce a true statement. If you are ending up with a true statement, then the ordered pair is a solution. Let's look at this example. Is the point 0, 2 a solution to these inequalities? We have two separate inequalities. The biggest difference is the inequality symbol. This one is less than, and this one is greater than or equal to. Let's start over here with number 1. We're going to plug in the point 0, 2. So 0 is our x value, and 2 is our y value. We're going to use our order of operations to simplify. And we get 2 is less than 2. That is false. 2 is not less than 2. That means that the point 0, 2 that was given to us is not a solution to inequality number 1. Let's check it in number 2. We're going to again substitute in the 2 and the 0 into their appropriate variable places and use our order of operations to simplify. 2 is greater than or equal to 2. This is a true statement because of the line underneath our inequality symbol. That means we can be equal. 2 is equal to 2. So this is a true statement, which indicates that our original point that was given to us is a solution to the inequality number 2 over here. Let's do an example together. Our task is to select all of the points that are solutions to this inequality, y is greater than x minus 4. And just something to remember up here, a lot of times the number line can be helpful to visualize integer comparison. So if you need to know which integer is smaller, an integer is smaller than everything on its right. So for example, -4, which would be right here where I'm pointing, is going to be smaller than anything that's to its right. So -2 is right here. That's to its right. That means that -4 is smaller than -2. Even though the number 2 without the negative looks smaller than the number 4 without the negative, just remember this rule right here and you will be fine. An integer is always smaller than everything to its right. Let's just check these one at a time by using the method we did on the last slide. Let's plug in the 0 and the 3 into our y and x places. We're going to simplify and see if we get a true statement. For choice A, we do get a true statement. 3 is greater than -4, so choice A is a solution. Let's check B, C, D, and E. So the only choice that is not a solution to this inequality would be choice E right here. So A, B, C, and D are solutions because when I plug in the coordinates, I'm getting true statements. That means they are solutions to the inequality. Go ahead and try this one. If we go ahead and we plug in A, B, C, D, and E, the points, we are getting these values right here. So B, C, D, and E are solutions to the inequality because they produce true statements after we evaluate at those coordinates. Here's another learning target. I can graph the solution to an inequality in two variables. Here's what you need to know. We first need to determine if our inequality is in slope-intercept form. So that's the y equals mx plus b, but instead of the equal sign, we'll have an inequality symbol. If it is in that format, it's easy. We follow the same steps as if it was an equation. We plot the intercept first, and then we're going to start at that y-intercept, do our rise over run, and then we have 2 points, and we will connect those points with some form of line. We'll talk about the dotted versus solid line in just a second. And we also need to shade. So if you look over here on the right, you can see a little bit of what I'm talking about. The top 2 graphs have dotted lines, and we also have some shading. And the bottom 2 graphs have solid lines, and we also have shading. We'll talk about that in just a second. But the process of plotting the actual line, like the direction and the location of that line, is the same as if this was an equation. Now, if we are not in slope-intercept form, here's what you need to do. You can pick any two x coordinates to plug into the inequality. A lot of times I like to use 0 and 1 because they're pretty easy to plug in, and the answers will be your y coordinates. So when I plug in 0, I get an answer out. Then it will make my point 0, comma, whatever you get as your answer. Same thing by plugging in a different value. And you can choose any two x values that you like. I like to use 0 and 1 whenever I can because they're super easy to plug in. Here's how you know what kind of line to use. A dotted line means that the points along the line are not solutions, okay? It's kind of like can't touch this. We're going to dot the line. That means I'm not including the points that are along this line. I'm just showing where the line exists. A solid line, however, means that you're actually including, you are grabbing every single point along that line. They are solutions, they belong to your inequality. You want to grab them, so it's a solid line. The shaded region is going to show you all of the possible points that could also be solutions. That's what makes an inequality different than an equation, is that you have a lot of possible solutions, but they lie within a shaded boundary on the graph. It's a good idea to always check your shading by picking a point in the shaded region to test. If the point that you pick is a solution, then you know that that's the side of the line that you need to shade. Let's take a look at this example right here. The graph is shown for you, and our inequality is y is less than 3x plus 2. Let's see how we got these values. The inequality is already in slope-intercept form for us. That means we're going to start by plotting our y-intercept, 0, 2, that's the blue point. And then we're going to use our slope, which is positive 3, or rise 3, run 1. So you can see from the blue point, we go up 1, 2, 3, and run 1 space to the right, and plot that point. Now I have my 2 points, that means I can draw a line. I just need to know if my line is solid or if it's dotted. Since my symbol does not have the equal sign underneath, it means that I do not want to include the points that sit along the line. I'm going to have a dotted line. Now we're going to do our shading. Since y has to be less than all of that, I want to shade below the line. So you can see this orange arrow right here is pointing down, and that's going to show you which side of this dotted line we're going to shade. I'm not shading over here because that would be above the line. I'm shading over here because I can draw a line down to include that shaded region. We can test a point to make sure that our shading is correct. So you want to pick any point that's in that orange space. I'm picking 0, 0. It's in my orange space, and it's really easy to plug in. So you plug in 0 and 0 for x and y. See if you get a true statement. 0 is less than 2. Since that is a true statement, I know that I've shaded correctly. Any point that's in this orange space would be a solution to the inequality. Go ahead and pause and try this one. Notice that your inequality is in standard form. It is not in slope-intercept form. That means that we can either rearrange it and get it in slope-intercept form, or we can go ahead and just find 2 points to plot. Hopefully you evaluated at some easy x values, and just treat your inequality as an equal sign while you're working, just for the sake of finding some points. I'm going to choose to plug in where x equals 1, and I'm getting y equals -2. That means that the point 1, -2 is on the graph. You can see that green point popping up over here. That's the coordinate 1, -2. Let's choose another point. Let's try plugging in x equals 0. When you plug in x equals 0, you get that y is equal to -1. There's the point popping up right here. We need to know if we're connecting these with a solid or a dotted line. Since my symbol has the equals line underneath, that means I can include the points that sit along the line. I'm going to have a solid line. Now I need to select my shading. Since y plus x is greater than or equal to all of that, I'm going to shade above the line, draw a line going up from your graph. Let's pick a point within the orange shaded region to test. Again, 0, 0 is a super easy point to check. Plug in 0 and 0 and see if you get a true statement. Since 0 is greater than or equal to -1, I'm getting a true statement. I will shade the region containing that solution. So 0, 0 is a solution. I know that I shaded correctly. If you want more on this topic, be sure to check out the Learning Target spreadsheet for additional resources, videos, and practice.